Please take note of our antitrust code of conduct. And with that, I would like to hand over to our first presenter, Simona Scandurra.
I'm Simona Scandurra from University Federico II of Naples in Italy, and I thank you for this opportunity. The project that I'm going to present concerns a collaborative work of Federico II University of Naples with Italian company HKUST Software, with which our research group has been working for years on the subject of BIM applied to historical heritage. Specifically, the State of Preservation Domain project intends to systematize the processes of knowledge and the intervention on historical heritage, identifying procedures capable of translating the complexity of reality without losing the specificity and uniqueness of the individual artifact. We have focused on how to formulate the pathological state of decay and alteration of building materials, structuring a domain standard, because this information is useful to safeguarding the existing building over time. Two specific goals were therefore identified. Create workflow that are standardized and openBIM oriented, and organized in an orderly and accessible manner the complex technical, specialist, and historical documentation on the subject of conservation and management of existing architecture. In fact, it is well known that there is no possibility of automatic semantic enrichment of architectural heritage data. It therefore seems appropriate to identify knowledge systems that guide operators and fully exploit the information potential of BIM, and above all, of openBIM systems. The project born in Italy, a country that, as well known, has a large amount of historical artistic heritage in its territory. In fact, there are buildings that are iconic for the history of architecture, and entire cities such as Florence, Rome, Naples, that are known all over the world for the architectural features that represent them. Italian territory is rich in a diffuse, lesser-known heritage, although very important, that needs significant valorization, management, and intervention to prevent decay caused by natural events or human negligence. More specifically, the project originated in the city of Naples, where there are numerous churches of historical interest, many of them closed because unsafe or difficult to maintain. The importance that Italy gives to its heritage also comes from the strong tradition with regard to restoration. In fact, the theories of restoration known throughout the world were born in Italy, and numerous international documents on the subject follow Italian principles. Italy's historical and literary tradition is also reflected in the development of legislation on the restoration of historic buildings and how they should be documented. An initial technical and graphic result was the Normal Lexicon in 1979, which proposed different pathologies to which stone materials are subject, and a legend useful for standardized graphic representation of the various phenomena. The international interest in the subject also led to the structuring of various thesaurus proposals aimed at identifying a unique language. There is, for example, the illustrated glossary of ICOMOS, which identifies pathologies on the basis of macro phenomena of reference. In order to document degradation, technicians describe in detail all phenomena they recognize, specifying technical references and possible methods of intervention. Alongside this, it is necessary to produce graphic documentation to describe phenomena and make them comprehensible through a clear legend. These procedures highlight many critical issues regarding the way is structured no graphical information and the way it is communicated. Moreover, representation are two-dimensional for phenomena that are distributed three-dimensionally in reality. And use of graphic symbology demonstrates the inexistence of a unical solution in the production of data and its communication. What we have seen so far is the framework in which our project is born. The actual start of the project took place a few years ago when we decided to translate, at least geometrically, the data described so far into a BIM model. In order to document in BIM the information of state of preservation of historical artifacts, a scan to BIM approach was considered indispensable, and therefore starting from 3D reality-based surveys to generate a BIM model of the artifact and find the right tricks to model in 3D even the phenomena of degradation. So HKUST Edificius authoring software was enriched with tools specifically dedicated to document decay phenomena. This is a special feature of the authoring software that helps modeling without finding a subjective solution, as is the case of the other platform. Among the many churches in Naples, the case study of San Pietro in Vinculis was considered for the verification and validation of the workflow. The church was modeled in Edificius software, where distinguishing the elements of historical architecture with systematic reading. Subsequently, documentation of decay was added to the mode which we see here, in particular on the main facade of the church. In order to model the degradation phenomena, it was necessary to refer the work to all technical documentation and normatives. Finally, everything was transferred into BIM. In Edificius software was also included some information on the various recognized pathologies, which clearly remains tied to the authoring software. The advancement proposed in this project is to transfer the enormous weight of knowledge required to document these phenomena into a standard and totally open BIM systems. So far, we have seen how we have addressed the issue of graphic modeling over time, but the state of preservation cannot ignore no graphic information. In fact, our research and the related project focused more specifically on how to organize information data to make it uniquely applicable and recognizable in a standardized, shareable, and open form. The challenge of the project is to obtain unambiguous information. Therefore, technical and theoretical knowledge on the subject was gathered and concentrated through the BSDD data structure. With this in mind, it was decided to define the state of preservation domain, validated in beta version, by coding the various pathologies that afflict existing architecture into appropriate classes characterized by properties that decline their specificity. All this to be applied and consulted on any model in IFC format. In order to prepare the domain data, first of all, were distinguished three categories of materials mainly used in construction: stone, wood, and metal. Taking into account existing glossaries and thesauri, all the pathologies that afflict material have been catalogued, distinguishing, for example, regarding stone materials, degradation from alteration. To this initial organization into classes and subclasses of pathologies were added a series of properties deduced from experience and from technical data sheets derived from regulation in order to ensure complete information. All of these was then reorganized and structured in a standardized way using the HKUST editor tool, which guides the creation of JSON file according to the BSDD guidelines. In this specific case, the domain state of preservation was then assigned, and the data classes and the subclasses were generated from the distinction of building materials and pathologies in degradation and alteration, as in the example shown in the figures. Assign to each class a unique code. Subsequently, forms all of the properties attributable to each specific class, taking into account technical and environmental data, and therefore all data that must necessarily be considered in the processes of evaluating phenomena. In conclusion, classes and property were associated, also pre-compiling the possible values of each property. For example, the property type of mechanism concerning the pathology chromatic alteration as possible values the nature of the mechanism at work, like chemical, physical, biological, and these for all possible data. Once completed, the JSON file was uploaded for validation. So, why does this support operators? Because if you must intervene on a building of historical interest, operators currently have to put together a lot of data in order to understand how to operate, without neglecting structural requirements, historical value, possible causes of degradation, possible development even. In our case, the domain made available through BSDD concentrates all information in one place, becoming the only reference necessary for the technician to decide what to do. So, quickly recalling our initial purposes, the project succeeds in providing answers by channeling complex but indispensable knowledge for decision-making processes, making it organized, available, and all based on openBIM tools, because it uses IFC models and uses BSDD mode. So an operator can upload in HKUST browser is our IFC model, in which he will have modeled in the parts of the architecture or the specific degradation phenomena. Then he can call up the HKUST BSDD application to select the classification of interest. In our case, it is therefore the state of preservation classification. And he will be able to assign to each part of the model the specific class of degradation or alteration, filling in from the drop-down menu all the property necessary to define each attribute. These to support the processes of analyzing the vulnerability of the artifact and deciding on the type of intervention required. The specific tools also facilitates the overall reading of the documented phenomena by allowing a quick graphic reading differentiated by color. but also a quick single or multiple selection for each specific class of degradation or alteration. In this way, the user can immediately understand the spread of the phenomena by tracing possible causes more easily. The greatest advantage of all the work is the absolute independence of the information from workflow constrained by authoring software. In any EFC viewer, in fact, the user will be able to consult the data of the state of preservation domain associated with each part of the model, becoming a shared, unambiguous, standard language, and therefore consistent with openBIM principles. All these supports the technician in compiling the information and deciding on intervention, allowing a reduction in time during the diagnostic phase, but also presenting itself as a potentially useful tool in predictive restoration processes. It is also a useful tool that supports public administration because it organizes data according to precise coding. This allows the administration to ask the technician exactly what it needs, establishing the level of information that is indispensable. In addition, the organization and standardization of the data also makes it easy to verify the BIM product using artificial intelligence processes. And this clearly helps and optimize the whole chain of activities. In conclusion, the result achieved by the project make it possible to streamline survey procedures related to historical heritage, because it organizes a vast technical and specialized knowledge of interest to engineers and architects. Although it is a tool that stems from technical regulation, treatise, and Italian experience, it is a useful tool that can be extended to an international context and that finds its solution in the relationship between IFC and BSDD, and therefore free-to-use tools. The proposed work seeks to improve the efficiency of processes related to existing architecture, both historical and non-historical, because all existing buildings, including tunnels, bridges, needs a phases of reading the state of conservation, and tools that make this phase framed in a shared and understandable language. This is to support maintenance and management, as well as the restoration. Users of BSDD can verify the validity and conformity of the data. They can work on their BIM in a system that remains free, always implementable, and upgradable. Because it uses a rigorous methodology and openBIM tools for great efficiency and quality. So this is a short summary of the tools used in our project. Thank you for your attention.
Thank you, Simona. We will do questions at the end of the session, so if you could just stay online and wait until then, I'll bring you back on stage.
Okay, thank you.
Thank you very much. And now I'd like to introduce Alexa Mitchell from HDR.
Good afternoon, everybody. Very excited to be here today. Can the people online hear me okay? Good? All right. My name is Alexa Mitchell. I am the Transportation BIM Program Manager for HDR, and I'm also the technical lead working on this project with a whole lot of other people. So I'm very happy today to be talking about the BIM for Bridges and Structures Transportation Pool Fund. So let me tell you a little bit about the project itself. Next. So this is an effort in the US that is taking 24 state DOTs plus the Federal Highway Administration to set the vision and the funding mechanism to create a standard that it is specific for data exchanges of bridges. So that is the high-level objective. This project has been going on for 4 years, and there has been a lot of work that happened up to this point. A lot of research, a lot of gap analysis, some work on the IFC 4.2 schema that was taken to what is going to be the 4.3 now to include all of the bridge information, but there were a lot of gaps. And so our project sponsors, and this is the vision for the entire state DOT industry in the United States, represented by the American Association of State Highway and Transportation Officials, AASHTO, to set the vision. And this is just the first step in achieving the vision that they've set out, which is the implementation of digital workflows throughout the life cycle of an asset. And by that, we mean we want to get rid of any drawings that we typically produce as documentation. And in order for us to do that, we really need to have a national standard. As you can imagine, in a big country that is segregated in terms of the states, and every state is autonomous, every state has their own standard on any BIM deliverables or CAT deliverables, and the way they organize information for bridge data, even though everybody has to report on the same federal requirements. So it was monumental that they got together and set the vision at the Committee of Bridges and Structures for AASHTO to say, you know, we just really need to come together and define what we really need to move industry forward. And that was the objective of this. For this particular project, we're tackling the first phase, which is creating the data exchange standard from between design and construction and to facilitate fabrication. And then in a later phase that it has not been funded yet, other use cases. Next. So why is this project important in terms of using open data standards? Comprehensively, this project touches on every component that is required for open data standards. We have very specific outcomes, so we're very focused on the deliverables for this project. The first thing was developing that information delivery manual. Exactly how we are going to categorize the bridge information, the bridge elements. And so really that was the first step, right? We needed to agree on how do you conceptualize those elements, and it will provide the, I would say, the cookbook, if you will, the recipe for all the other technical components that are necessary to achieve open data standards. And it sends a signal, a clear signal to all the technology providers that this is the direction our industry is going. So no longer are you going to have to do a standard for this DOT, and this DOT, but for the whole 50 DOTs in 4 territories, this is the way we're going to do business. So that was pretty monumental. The second outcome is the model view definitions. Once we know what information we need, it is time to translate that narrative that the subject matter experts, bridge engineers that produce drawings and construct bridges, now we take that narrative into computer language so that we can actually achieve an export for the IFC standard. And along with that, of course, we had to create a data dictionary, another component of the ecosystem for open data standards. So now we have information delivery manual, data dictionary to go with it so that it can be uploaded to the BSDD and benefit the entire international community. And the next step was to work with the technology providers in creating the certification materials and the instructions, that the test suites that they can use, so that we can validate that each of their products will indeed give us the functionality that we're asking for. Because the problem today is everybody uses different software. As a designer, I use one software, contractor may use another one. And what we don't have very well defined today is that export. I need to be able to share information with other stakeholders. And that's the power of BIM, right, is collaboration. But if we are locked down into a proprietary solution, it's very difficult to do that with that validation, with that maybe re-inputting all the data, validating the data, that everything came through equally. We want to make sure that we get to a point where everybody is seeing exactly the design intent, and everybody's on the same page. And lastly, is the deployment of stakeholder training. So we are trying to hit every single component that it is critical to successfully implement open data standards. And that is the last piece, right? So this outcome number 3 was training the technology providers. Outcome number 4 is training the owners and the people producing the information on how to use the new standard, how to work with the technology providers to learn the technical portions of how to do the exports and how to map information so that you can export it correctly. So we felt that these 4 foundational components were absolutely necessary for successful implementation of this standard. And we want to make sure that we have a standardized certification process so that there is no room for interpretation on how to implement the standard. Next. So, continue to the key outcomes here. We really believe that this is going to be a game changer, not only for the US, but for the rest of the VSI community, because we have provided those key components to enhance interoperability. The process, we've developed the process with the IDM, and now that formalizes that process for how the information needs to be exchanged, but it also sets the process for other data exchanges. Now that we have this process in place, creating other use cases is going to be much easier. The service, we have a data dictionary. We'll be able to clearly define all the ontology, right, in all the taxonomy and every piece of information that needs to be defined. The data component and the MVD, or now the IDS, the resource for vendors to create those import and export features that are so very much needed, plus the validation tools that we need to ensure that we indeed get what we needed. And the business portion of this is certification materials. We need to make sure that there's a way that we have to provide that confidence to the owner, to the user, that the software accurately exchanges the data as we intended it. And why is this project significant? Well, number one, I would say that this is the first US standard for bridges 3D model data. We didn't have anything like this. And so we are setting the stage for more to come. It enables really data fidelity and enhances interoperability. You can have interoperability without data standards, but it is not an easy thing, right? You have to require people to use the same software. So we are saying we are going to be able to exchange data confidently, and we're going to enhance that collaboration through interoperability. This is a big one, which we've been working with technology vendors, and it sets the direction to why a technology provider needs to invest in putting these tools into their software. It is not just one customer, it's not just one project. It is 80% of all bridge projects in the US, right? So not the big, complicated, complex signature bridges, but the everyday bread and butter type bridge that you cross every day on your way to work. So it sets the direction for the technology developers, but it also the entire supply chain. Now, designers, contractors are all on the same page because everybody agreed to one standard. And that is significant. And we didn't start from scratch, right? We use all the efforts that BSI has been working on for many years on taking it to the next level and be able to contribute to the community and continue to advance the standard. This is just one of many projects to come. And we believe that now that we have done this, the next is going to be much easier to convince and to create the business case for more funding for additional projects. And we set the framework for other information delivery manuals. And I am happy to say that on June 22nd of this year, the Committee on Bridges and Structures from AASHTO passed unanimously the adoption of this information delivery manual as an AASHTO guide specification. So anybody in the world will be able to go to the AASHTO website and purchase this standard to download it and use it however they want to use it. And for us, that was important, that the standard is not only a technical standard, but it is endorsed by an authoritative source of standards. Next. And I can't leave the conversation without talking about the incredible team that we've had. It takes a lot of people to get this to work. We need a good team that understands every component, because not everybody can be an expert in everything, right? And so we have people that are very knowledgeable in the BSDD process. We have IFC development staff that works not only on our project, but also BSI international projects. We have an ROI component on this project, which I failed to mention, but we did because that's part of creating the business case. And the ROI for this project is to demonstrate the value of continuing to support the development of IFC and other open data standards. Education and engagement. We need to facilitate those conversations with everybody. Everybody needs to come to the table. And we can't do this without the technology providers. It's absolutely critical that they come to the table, not at the end of the project, but as an active participant of the project. We have great industry involvement. We have over 20 technology providers that have signed letters of commitment, indicating that they are on board and they will do what they can to be successful on this project. I think that is it.
Thank you very much, Alexa. Now I'll be pleased to introduce Jack Cheng from the Hong Kong University of Science and Technology. Hi Jack, can you hear us?
Hey, hello.
Hello, can you hear us?
Good afternoon, everyone. I'm Jack Cheng, and let me share screen right now.
Perfect.
Can you see the screen?
Yes, we can see your screen.
Okay, thank you very much. And I'm Jack Cheng from Hong Kong University of Science and Technology. Sorry that I cannot join all of you in person in Canada, but I hope that I can make my presentation clear virtually. Today I'm very happy and thanks for having me here to share with you the topic on secure openCDE with blockchain for HKUST Campus-wide Digital Twin with openBIM and openGIS. So we would like to integrate different technologies for a sustainable digital twin for the campus, and we try to use our university as the test case. This project have three main objectives. First of all, we would like to develop a digital twin which is campus-wide for the entire university so that it can be smart and also green. And to achieve this one, we need to use different technologies including BIM, GIS, IoT, and building management system. And to integrate all of them, we need to use different open standards. And also we integrate all this data into common data environment. And also we hope that through these open standards, then we can really support facility management tasks, including engineering, analysis, and also operational maintenance. And we also have a website to show all the details. And in the following, I will give you more details. And in this project, we have adopted different open standards, including openBIM standards, IFC, and we found out that when we try to model our buildings, some components like the ATM or water fountain, etc., are not included in IFC. So that's why we extended the IFC schema to fit the needs of our campus. And at the same time, we try to integrate openBIM with the building management systems. And we found that using open ontology called brick schema, we can better illustrate and better connect some equipment and HVAC control, etc. And to perform this one, we also make use of MVD and also IDM to extract the information from BIM model to support energy simulation and also BMS integration. We also make use of openGIS data and called CTGML to link up with BIM and GIS. And we also try to manage all data in CDE, Common Data Environment, and we try to secure the CDE using blockchain technologies. And we actually have used the buildingSMART openCDE API in this exercise. And in the project, the final outcomes have four main parts. First of all, we have extended IFC schema so that we can have the geometry and also semantic information about the built environment. And then we also have a single repository of all the buildings on the campus, and then we can have better decision making, including like walkability. And then we link up with building management system and also HVAC components through the open ontology called brick. And then we also integrate blockchain with openCDE the protocol. And these are the teams that have been involved in the project. I have the team on digital twin and also team on blockchain, and these are the members working together. So actually thank to all of them. So in the following, I would like to give you a little bit more details on the different parts of the methodology that we have adopted, and then how we implement this one on our campus and what are the actual outcomes. First of all, some basic background. We actually look at the ISO 19650 on the information management, and this is actually the motivation of what we are doing. We try to consider the AIM, the Asset Information Model, so that we can support the asset management. We refer not only the ISO standard, but also refer to the Hong Kong CIC BIM Standards General, which is also a local annex of the ISO 19650. And if we look at the ISO 19650, it talks about the relationship between OIR, AIR, AIM, etc. And when we build the digital twin, we actually try to not only integrate the AIM, but also try to consider IoT, like sensing, BMS, and to support AM, FM, we also need the support of people, the technology, and also the workflow. And in fact, open standards can support all of this, and people also will be very important. So to support this one, we actually build a digital twin. For digital twin, we refer to the National Digital Twin reference or guidelines from UK, and in the guideline, it actually mentioned that we have the physical world and also the cyber, the digital world, and we can go and use IoT to know what is happening in the physical world, and then we can support the decision so that we can better and also try to control the physical environment. With this one, and that is why we are interested in digital twin, because digital twin can really help us to manage or can make our built environment greener and also more efficient. To support this digital twin, in fact, it is not only about building information model, it is also related to many other technologies, including laser scanning, simulation, IoT, blockchain, CGE, etc. And we try to consider all of them in this project. And these are the list of the benefits of BIM or digital twin for AM, FM in general. In summary, through digital twin, then we can have better decision making, high productivity, and improve responses, etc. So all these are the background why we are trying to use digital twin for AM, FM. But when we work on the digital twin, we actually face some challenges. And the first challenge is we found that there are no harmonization between different tasks, different projects. And then another is we don't have the software support. When we try to use different software to support different tasks, we found out that there's actually a missing gap in terms of interoperability. And also, we hope that we can use a single model that can support multiple tasks, and including like space management, the engineering analysis like CFD, and also to generate drawings, and then to connect with BMS, etc. And with all this, we actually found out that open standard can actually help us. And with open standards, including openBIM standards, we can integrate different systems, we can integrate different tasks, and this is actually why we found out that open standard can have a high potential. So in the following, I will talk about how different open standards have helped us. First of all, is about openBIM standards. buildingSMART International have a few openBIM standards like IFC, MVD, and ITM, which are the focus and which have been used in this project. And these standards are very mature, and then but when we apply this one to our campus, which consists of more than 60 buildings, and we found that we shouldn't only use BIM, but we also need to consider GIS. And when we integrate BIM and also GIS data, we found that we actually need to extend the schema so that they can talk to each other. So that's why we also look at openGIS standard. Particularly, we look at CTGML standard. So in this CTGML standard, we try to consider how different buildings are represented in 3D, and then compare this one with IFC. And we also make use of the I3S, the index 3D scene layers standard, which shows how 3D models should be represented. And integrating openBIM and openGIS standards, then we integrate this one with CGE. Okay, so that's why we try to look at CGE, because when we try to group all these models together in a single platform, we hope that we can really achieve the so-called single source of truth. And when we deal with different software, we found out that we need open standards so that the CGE can be in sync with different systems. So that is why when we consider the CGE concept, we have the work in progress, share, publish, and archive, but to communicate with all these different systems. And then we use the different standards to support this. In particular, CGE have a few requirements that I try to summarize here. First of all, we want to make sure that the data in CGE will be correct, and also will be consistent, and also will be complete. And then at the same time, we also refer to we are also concerned about the security of the data in CGE. We refer to the ISO 19650, and which talks about the security-minded built environment. And that is why we, in this project, we also make use of the blockchain to integrate with the openCDE. And for openCDE in particular, we use the buildingSMART openCDE Foundation API so that we can integrate software with CDE more seamlessly. And at the same time, we use the Documents API so that we can upload, download with files with the CDE and have better interaction. And in terms of the security and also the correctness, consistency, and completeness, we make use of blockchain so that we have a trace, we have the audit trail, so that we can have the traceability and also irreversibility of the data that we store in CDE. And with all these, then we have the openCDE, open standard with Digital Twin, blockchain, and for access management. And to do this, so that's why particularly we have all these open standards to support the integration, particularly with BMS and also FM. And we found that we need one more thing, which is the open ontology, so that it can be a high level regardless of the brand of the BMS. And then we can still communicate with different BMS systems for different buildings on campus. And that is actually our vision. We hope that we have a single source of truth for the digital model for the entire campus, integrating with the BMS, integrating with the FM system, integrating with different mobile platform, and also support different engineering analysis. And open standard actually help us a lot. So in the following, then I will briefly talk about the methodology and then about the case. Particularly, there are 4 aspects. First is about using openBIM, particularly IFC, and then we use CTGML for integration with GIS. We use the brick model to integrate with BMS, and then we use the blockchain and openCDE API. So we have developed the 3D model, and then we use the openBIM platform and IFC to represent the 3D model. And in particular, as I mentioned, for this one, for the IFC, wall, column, etc., we extend the attribute list so that we actually look at what users or the people on our campus need, and then for the facility management, and then we try to also include those in the attributes of the corresponding object in IFC. And then we also compare IFC with Revit, and then try to see what are the information mapping. So we try to map this data so that when we import Revit, then we can still get the corresponding IFC object. And then for the IoT, we actually make use of the IoT portal provided by our university for different kinds of data, sensing data, etc. And then through the openGIS and also the JSON format, then we can integrate with the IFC model. And in particular, we try to use the IFC model and then extract the building geometry so that we can support different applications for FM. For example, evacuation. This is one example that we try to use the 3D geometry and then also CCTV data so that when there's, let's say, a fire, then through the sensing data, then we can know where to evacuate. And then for GIS, then we also extend the CTGML standard, in particular, like the IoT sensor, water fountain, printer, etc. And with this one, then we have this extended schema shown on GIS platform. And then for the IoT, then we also have additional attributes. For example, like location, the people count, etc. And we also use this data to support other research initiatives about like the prediction of the people in different locations in the future. And then for the integration of the IoT, then we use the open ontology. Particularly, this is called a brick schema. brick schema has the advantage that we can use this data and then also customize the data schema, and then we can fit this one. So we actually extend the brick schema, and then we can fit into the model. And then in particular, this brick schema allow us to have the ontology and also the first order logic. For example, we can also have the query. For example, if we want to find a particular VAV to support a particular room, then with this kind of the logical representation, then we can do a better search regardless of the brand. For example, on our campus, interestingly, our a single building may have two BMS. One is Honeywell, one is Delta. So, but using a single ontology, then I can have a high level encapsulation of all this. And then we can also use the MVD to extract the information to support the engineering analysis like CFD, so that we can have a green the green environment, and then we can know how we can operate our building. And then the last is about the blockchain. Blockchain, then we try to have a record of all the changes. In particular, we design the data structure of what we want to keep record, and we actually extend this one with the workflow. And here we can see that we have the maintenance request, and then we have the maintenance work order, etc., which we want to keep it private, keep it confidential. So we blockchain them, and also we have a record about who actually have made the request, who have made the work order, and then what is the status, something like that. So we actually apply this one to the Hong Kong University Digital Twin, and this project we started in 2019, and we have successfully built a 3D model of more than 60 buildings with more than 20,000 rooms with the unified room attributes. With this, then we have the single platform that integrate IFC and Revit, and also we compare all these models in the terminologies, the GIS and also the BIM models. We also have this platform, web platform, so that we can see the 3D model at different scenarios. And then we also link the BIM model with different IoT data. So this one is an example that we can jump to a particular room, and then we can see what is the real-time the IAQ information. And then we also integrate this one with the mobile platform, and then we can see what's the direction that we are suggesting the pedestrian to walk through according to the number of people at different locations. And then to integrate with BMS, we use the ontology called Brick, and then this is the instances and one example of that. And in particular, we actually can define all the thermal zone of different areas, and then we can also see what is the current condition of that. And then this one is the illustration of combining the blockchain with the openCDE. So here we can see that we have a GIS platform, and then at the back end we have all this data, and they are secure. And then we have all this the B model with the drawings, and we make use of the ArcGIS GeoBIM. And then this one is an illustration of all the e-signature, and then this is what we want to have, a single source of truth of all the document. So at the end, this one actually lists out all the benefits of the open standards in our project. With open standards, we actually can conduct all these, perform all these facility management tasks in a shorter time, and this time actually consider the manpower. Then this is the saving that we can calculate. Also, using openBIM standard, then we can have better analysis of the model, and then we have better operation, and it actually is the saving of the energy. We also have a better integration with the IoT, and particularly I think that this is something interesting and very useful is we can have a single source of truth and single source of view. For example, with the single model, we can generate the floor plans that can support many different applications for students, etc. And the lessons learned is that standardization is very important, collaboration among different people, and also technical support from the solution provider are all very important. And these are the benefits, including saving in time and also promote the open standard to our in-house and also stakeholders, and also it can support future research. So yeah, the innovation of all these, actually I've mentioned at the very beginning, the extension of the IFC, extension of the CDGML, and also extension of the open ontology and integration of all of that to support the openCDE with the blockchain. And we are very happy that in Hong Kong, we also have the openBIM openGIS award, and we have got the grand award of the competition this year. And also this project also have got the Hong Kong Construction Industry BIM award 2 years ago. So the future direction, we want to extend this one to walkability, sustainability, and also we through the CDE data, then we can do the facility maintenance much more efficiently, so that we can keep track of all the maintenance work order, and then we can have the object-based, room-based level of the analysis. So this is actually what I would like to share with all of you, and thank you very much to listen to this presentation. Thank you.
Thank you very much, Jack, and to all of our presenters. I'll bring our virtual presenters back online, and Alexa, if you'd like to come up to the front, we'll now move on to Q&A from the jury.
I have a question for Simona. How are you? Congrats for your presentation of all of you. Can you explain us a little bit the range of your main intervention? Because you have laser scanning, modeling, then the uploading to the BSDD with the ACA tools, but there are lots of things that were already there. What you developed was essentially this ontology, this semantic, this preparation of the classification of the problems. Can you please explain to us exactly what was the main the achievement that you consider in your work, please?
Okay, I put together every information about decay and alteration, study every normative, technical information, particular organization of information that every architect have to study in every moment that work on heritage. All these type of information was organized to show the properties and all you need to study to appreciate, to affrontare, to work on architectural heritage, on architectural, historical architecture. So I have organized all this information to have one type of way when we want to work in this thematic. I don't know.
Process,
to build a unique process, yes. And then I development the BSDD on this information and to make this available for all operators. Yes.
I hope you have a good result. In order to proceed with this, I think you understand and agreement of the government official that is the ordinary is important. What did you do to do this? What did you do? Government official
not sure I understand the question. Can you repeat it again?
So let me support her.
Okay.
So basically, you explained about the whole process for the bridge construction with openBIM. But in my understanding, somehow government, when the company work with the government, there are so many government authorities. It's really hard to communicate, make them understand, because they have their own structure, and usually company they have some biases. This is the commercial somehow. So there are so many conflicts with each other. So in the whole process, how did you communicate with the government authorities? And then how do you make them because you said everybody has a full agreement for that. But during the process, I think there's some challenges. How did you overcome to implement the openBIM in that authority? That's very good question.
I understand. Thank you. Thank you. So the interesting
And that was
part.
tough to get in a sentence, right?
Thank you. Thank you. So the interesting thing about this project is that the government agencies were the ones who initiated the project. They're the ones who said, we have this problem to solve. We don't know how to solve it. We need help from professionals and from subject matter experts to help us achieve this vision. So there wasn't a whole lot of convincing of the government, but there is a lot of engagement with the governments, the different governments, to understand their specific needs and come to consensus and educate them on what IFC does for them. So there's been lots and lots of engagement on a regular basis. We do educational webinars with the owners, with the government. For example, one of the major engagements was to come to a consensus on the data dictionary. That took many, many meetings because everybody has a different definition. They call things differently, or we don't do it this way here. And it took us a lot of meetings to accomplish that. So that is one example of how we worked with the governments to bring their vision to fruition, right? So but it was a very unique project because we didn't have to convince them. They needed to do this. They wanted to do that. Yes, sir.
Did you find some specific government that was promoting or focusing on a specific software, so was resistant on the openBIM process?
So most of the governments have standardized on one particular platform. It is true, but they want to get out of that lock. So they want to encourage. Yes, they do. They want to be able to allow their designers to choose whatever software they want as long as they can read the information. They may stay, and I believe they will stay with whatever platform they're using, but they'll allow anybody who does work for them to use whatever software they want. And so one particular thing that is unique to the United States is that many of the governments do their own design work. They don't hire consultants. And so that is one of the many challenges that they have, some states do 80% of the work in-house. Some states do 80% of the work by consultant. And so their needs are very different. And so there are states, governments that are more open to changing than others because they don't have that much to change internally, right? But yes, it is a great question, and thank you.
Thank you.
Thank you, Alexa. And tell me, just enlighten me on all the stages from the IDM, data dictionary, MVD, vendor certification, and training of the stakeholders, as we call them. What have you achieved? Because ASHTO already approved the IDM, right? But what have you achieved until now? Are we in the MVD part or what?
Thank you. Yes, that's an excellent question. And yes, we have just developed the IDM. we have done quite a bit of development on the MVD. We are getting ready to do proofs of concept because the 4.3 is not official yet, and so we don't want to call it final until it's finished next year. But we want to start demonstrating what we have been able to achieve to date. There is a lot of work. We are in the process of mapping and identifying all the different property sets that are not part of the schema today so that we can expand the schema to satisfy the needs of this project. So we are in that sweet spot. The data dictionary has been completed, but AASHTO has not officially joined BSI. They are actually in Orlando, Florida this week voting on their membership. And we believe and we have advised that they do use the service so that they can upload what we're calling the US Bridge Data Dictionary into the BSDD. But the data dictionary work is completed up to a certain point. We still need to translate that into the JSON format that is required for upload. But all of the content is there. And so really, we just need to bring it home with the MVD and the IDS specification now. So we're very close, and we have one more year. Thank you.
Are there any further questions for the jury, perhaps for the last presentation? Yep. Okay, we'll go. Yeah, I'll say first. Jack Chen.
Jack.
Hey, hello.
Hello, Professor Jack. How are you? Congrats on your presentation. Kind of a provocation for you. Did I see somehow in certain parts of your project that there are some closed parts in the middle of this all open that you promote, closed parts related to parts that are not totally and shareable, let's say, and open to the community, parts related with precisely with the part of the softwares and also the blockchain. I want you to please tell me a little bit more about that, okay?
Okay, the question is about what we can share to the community and related to blockchain or software specific.
No, the concept of open, you have big bin, little bin, open and close, right? You presented that the concept is understandable. So when we are talking about open, we are talking about open and shareable information, okay? And somehow I found in your process, I'm sorry, because I couldn't find it profoundly. So you please enlighten me on that. Somehow, some parts you need to enter on the software proprietary files and models and vendors. And how are you doing that? How are you turning those parts of the workflow open? What is the way that you are opening all the process? Of course, we need the vendors, all the vendors to enter, but they do that through IFC, through openBIM, through IDMs and the MVDs that we can draw, and the BSDDs as well. Okay, and in the blockchain, I found that essentially you are not closing, you are validating, authorizing the entrance, right? And you are doing that with the blockchain because it's so important, the area that is confidential, okay? Would that be possible to repeat in another examples in buildingSMART in other areas? That's my question, okay?
Mm-hmm. Yeah, very good question. Thank you. And in fact, this is also our intention that we want to focus not only this campus or this project. Hopefully, we can generalize the methodology to apply to other buildings. And in particular, the open part of this one is the data mapping approach. Particularly, for example, we try to look at the IFC and also look at the GIS. And then the IFC and also CTGML are the most commonly used the data standard for BIM and also GIS. And then we actually established the mapping between them, considering campus buildings. And also for blockchain, in fact, what we try to show here is only the workflow. And then for a general facility management, or particularly facility maintenance workflow, the use case, what are the tasks or what are the pieces of information that we want to blockchain? And then what are the data model we should have the blockchain? Different facility manager may have their different preferences, but I think this kind of the approaches would be generic, and then people can refer to this one. And also for the ontology, the brick ontology, we also extend the brick ontology, and also we hope that in the future we will have some ways that we can share this extended IFC or extended CGML or extended brick model to the relevant communities, so that the models can be enriched. In fact, we also have encountered or also involved in some other digital twin projects in commercial buildings, etc. We found that the requirement of the clients would be different. So I think the same data model may not be fully transferable, but I think this kind of the approaches would be generic, and then would be a good reference. I hope I made myself clear. Okay, yeah, thank you.
Perfect. I have one more question.
Yeah, one thing also I want to also supplement is that why we are interested to work on openCDE, because in Hong Kong we have the government have a target to have all the major projects, no matter it's public or private, to have 100% adoption of CDE by 2026. So that is why CDE would be our main concern about how we share information, how we store information securely among the whole industry. And that is why we are interested, and then also we have many opportunities to talk to the industry people on using open standard to also securely store all the information in CDE. And I hope that later we have more opportunities to contribute to this community.
Thank you, Jack. We have one more question.
So one of her questions is the level of detail of the property and then the geometry. Because you are working on the maintenance purpose, right? So for the maintenance of all the building, actually, when you make the BIM model, they're supposed to have some level of the LOD. So could you explain about the property perspective and geometry perspective? What's the level? And then how did you define that level is appropriate for the digital twin of the Hong Kong University? That's my question.
Okay. Also another very good question. In fact, we talk about LD or LIN here. It really depends on the application. So far, we focus mainly on the space management and also integration with the IoT data. So the model is about 300 in terms of the geometry. And we don't need to have the detailed model, particularly because for our campus, all these 60 plus buildings, we created the model from the existing buildings. So we actually based on drawings, and then we drew the model and then compare and validate using laser scanning technique. And so that's why we didn't have a very detailed model like 400. We only have 300, but I think we think that is actually sufficient, because in terms of the room level, or we want to have the map, or we want to have the analysis in terms of the ventilation like CFD, 300 would be sufficient. Yeah, but this actually is also the basis for the new development. Now we have new buildings upcoming, and then they create the 400 models for the new construction. And then we try to integrate the new buildings B model to our existing digital twin, so that we can update the digital twin. So in terms of the geometry is 300, But in terms of the semantic information, I think it's actually 500. But it really depends on what's the purpose. Like maintenance, then we keep all those documents, etc.
Are there any more questions from the jury at this time? In which case we will close the session. Thank you everyone for joining today. If I could ask the jury to remain in the room for deliberations and for everyone else to please now leave. Thank you.